hope everyone had lunch. This session is going to be just a chit chat. I don't have a lot of stuff to present. I've got one use case that we built at Bajaj Finserv Health. We'll just have a conversation about how did we build it, and I'm pretty sure all of you would know how did we build it the moment I start, right? So I'm Blessin George Varghese. I used to be a part of Bajaj Finserv Health. Now I'm pretty sure everyone knows Bajaj Finserv because of the calls that you guys get, right? Is there anyone who has not received a call from us yet? See, that's our achievement, 100% hit rate, right? So the most successful calling company, I would say, and we're proud of that. While we are trying to reduce spam, I'm not promoting spam, but then we are very proud of the reach that we get. Fun fact: iPhone 17 series got launched last week, right? One out of three iPhones sold in India are sold through us, right? So we empower the college kids to have a 17 Pro Max. That's what we do. All right. So I'm ex Bajaj Finserv Health. I used to be a part of Bajaj Finserv Health till last week. I stopped working there to start my own startup. So I was in Pune. I moved to Bangalore this week, figuring out a place to stay. So I'll launch my startup next week. I'll be working on the foundational Gen AI side. That's the domain. More about it later, maybe over LinkedIn or chit chat sessions. We'll start now. Once again, hi everyone. Please feel free to ask questions in between. If I know the answer, definitely we'll talk about it. If I don't know, I would love to know from you. If we both don't know, we'll figure out, right? So my entire pitch is about calls. How did we move from human-driven calls to AI-driven calls so that you guys get the best time for calls, we get the best conversion rate. When I say we, please refer to Bajaj Finserv Health. I'm still speaking from the context of last week. It's like GPT saying my memory was last updated on 2023. All right, we'll move. If you want to connect with me on LinkedIn, you can scan the QR here, or you can search for my name. Pretty unique name, so I don't think you'll find duplicates there. I'll move forward now. So the entire objective of this project was very simple. One, people hate it when we call them mid-noon while they're having lunch, while you're in an office meeting and saying, hi, I'm from Bajaj Finserv. Would you like to have a loan? Right? And it's like, yeah, I've just told you 100,000 times, don't call me back. 2 minutes later, you get another call. Hey, is it a good time to talk? Can I ask you if you want a loan? Are you planning to buy a car? And it's like, no. 3 minutes later, you get another call. And we got a lot of complaints, right? We got a lot of complaints about it and we heard it. But then we wanted to solve it. Now, if you look at a typical call center problem, don't worry, this is about Elastic, but I want to give you a background of what we were working on. If you look at a typical call center, the way it works is people, the call center agents, they come in at 9, they clock in at 9, they work till 4. They're employees just like us. But the issue is that we are also employees, right? We are working somewhere. So the timings are overlapping. So when they call, most of the people don't like to attend call at that specific time. And when are the customers available for a call? It's mostly from 5 to 7 based on statistics. And TRI doesn't allow, TRI is the regulatory commission, they don't allow you to call post 7 or 8 depending on use case, whether it's for insurance, support or whatsoever. So how do you make all these people call from 5 to 7? That becomes an issue of scale. Now, if I hire 100,000 employees, call center agents to make a call, then we have an efficiency problem. What's the efficiency problem? These people are sitting idle from 9 to 4 and they'll start working only after 4. So it doesn't do the math for profit. How do we solve this? We move to AI agents. And now throughout this next 15-20 minutes, we'll see how did we use Elastic to make it smarter. All right. Why? Because IVR is static and the conversion for IVR is very low. If I call you and say, hey, press 1 for getting a loan, press 2 for this, you're like, nee. Right? And I'll show you the statistics. When we started this out as a hobby project, we never thought it'll go up with numbers. We'll see the actual statistics. Our solution was AI call bot, real time. When I say real time, see there are multiple AI call bots. I'm pretty sure you must have received call from AI bots, right? And you must have seen this issue where when you say hi, it's like, hello, how can I help you? And you're like, you just called me, now you're asking me, how can I help you? That's the issue with real-time intelligence. And that's where Elasticsearch comes in and tells the bot what to speak. And compliant. I won't cover compliance here, but when you're working in the insurance space, compliance is a big part. If you don't follow, you're out of the game. That's how it works. How did we build it? If I have to tell you in 2-3 words, it's multi-agent AI. It's very interesting, the way agents switch and all those stuff, plus Elasticsearch for memory. We'll see this in depth. Now, for how many of you are from tech background here? Okay, how many of you are not from tech background here? Okay, I think I'm speaking to the perfect audience here. So there were a lot of open source solutions available. There were a lot of enterprise applications available, like 11 Labs and all those stuff. But the issue is that they don't solve for scale. At Bajaj Finserv, we operate at millions. We can't do 100 calls and be okay with it. We can't call a POC, create, cool, sexy, and be like, oh, this is what we need. No, unless your solution works pretty well in a solid manner for millions of calls, it can't be used. So that's where we decided, okay, we won't buy it, we'll actually build it in house. And we were like, okay, but how do we build it? I did not know, the team did not know, because Gen AI came into the picture, and real-time AI was not a thing, because when we launched it in 2024, latency was the biggest issue. Now we'll see what went inside it. First, the core, the heart, the fundamental component behind the entire thing is a voice-to-voice model. Right now, what's a voice-to-voice model? All of you have used chatgpt.com, right? The web UI. You must know that's not the model. ChatGPT is not a model. It's a web application over the GPT series of models. Similarly, Google AI Studio is not a model. It runs on top of Gemma or Gemini or your other set of models from Google. But those are text to text models, and that can't be used for calls. Most of the companies in India, including your top food delivery apps, I can't name any of them, but or your top fashion brands or Bajaj Finserv's direct competitor, what they do is when you speak to the bot, they record your audio, they transcribe the audio to text, ask this text model, okay, this is the input, what should I reply? The LLM gives the output in text, then you use text to speech, and then you play back the audio to the customer. Sounds good? But the issue here is that the entire round loop takes about 1.5 seconds, right? Now imagine this, you say hello, for 1.5 seconds there is no response, and then the bot says hello. See, you just hang up the call. That's what we've seen because we've tried that model. So how do you solve this? You use a native voice to voice model. Now what's a voice to voice model? It's pretty simple. There's no text involved. You give voice in, the model gives voice out. That's fundamentally what a voice to voice model is. And the most popular one out there is GPT real time, GPT-4o real time, or GPT-4o mini real time. These are the offerings from OpenAI. And then you have got Google Gemini with live mode, which essentially is again real time. Alternatives include your Whisper, which is not real time but comes close to real time. And if you want to try out something at your company for your hobby project, 11 Labs is great to start. And then telephony. See, now us developers, right? I or my team, we were used to building on our Macs, deploying it on a container, and then getting the API. But here the challenge was you have to deliver the voice through a phone. Like you have to dial in a Geo number, a Vodafone number, sorry, a V number, or a BSNL number if that exists. This was a challenge. Now, no one knew how telephony works. So, long story short, we had to go into SIP. So, this is the technology which powers your phone lines and all those stuff. Not going in depth there, but if you are interested in building this on your own, don't pay for it. There's an open source tool called as Asterisk. Just use Asterisk and read more about it. It helps you connect your APIs to phone calls. In short, all right. And then custom VAD. Does anyone know what is VAD? Anyone? Oh, perfect. What's your background, sir? Ah, precisely. I was surprised because until I got into telephony for this project, I did not know what is VAD. See, for LLMs, there's a big issue. For LLMs clearly knows, or LLMs clearly know how to respond when you give an input. Let the input be an image, let the input be voice, let the input be anything. But the issue here is that when I asked him, what's your domain, sir? He responded, right? How did he respond? What was the activity in his brain? Okay, he figured out Blessin George has asked me a question. He has stopped asking me a question. Now I have to respond. This is technically called as voice activity detection, VAD. This tells the model when to speak and when to stop. Now, if that went over your head, it just tells the model the other guy is speaking, you should shut up. The other guy has stopped speaking, you can speak. This entire loop is called as VAD. Now comes the complex part. In an ideal scenario, I'll be the only one speaking. Now imagine I'm traveling in a metro. I'll be speaking, there'll be guys speaking behind me as well. Now, how does the model know who started speaking and who stopped speaking? As humans, we have the capability to identify who started speaking, who stopped speaking and all, because we've got vision as well. We'll look at the guy. Long story short, LLMs can't do that yet. So we had to build our custom VAD, voice activity detection algorithm, which tells us if the speech is done or not. For the nerds in the room, it's long story short, it's a very simple implementation of moving averages over a graph. When you look at your audio sample and when the graph goes flat, that means there's no input. When the graph is still spiking, that means there's output. So you take a moving average sample. Moving average means the sliding rule. You do that when the average goes down, you tell the model, okay, now you speak. All right? And then retries and multi-line. I'll skip the telephony part. Backend, I love Node.js. So we did it in Node.js. You can do it in literally anything. So we had to do pre-processing, post-processing, and session orchestration. ANC, I'll skip the part. ANC is nothing but whatever tech you have in your airports, we had to write code for it so that the model doesn't listen to the other guy. The model listens only to one guy. And Elasticsearch, so move from here, our focus will be just on this part. We won't discuss the other parts. All right? And this is an actual customer call. What's the fun if I don't make you listen to it, right?
Hello.
Namaste, Yogita.
I also want you to focus on how there are background noises and the model did not respond to that.
मैं अदिति बोल रही हूँ डॉक्टर संदीप के क्लिनिक से। ये एक रिमाइंडर है आपकी अपॉइंटमेंट के लिए डॉक्टर संदीप के साथ आज शाम 5 बजे। कृपया बताएं क्या आप आ रहे हैं?
नहीं, मैं नहीं आ रही हूँ।
ठीक है, मैं डॉक्टर को इन्फॉर्म कर देती हूँ। क्या आप अपनी अपॉइंटमेंट रीशेड्यूल करना चाहेंगे?
हाँ, आप कल 3 बजे के लिए रीशेड्यूल कर दीजिए।
जी, कल 3 बजे का स्लॉट अवेलेबल है डॉक्टर संदीप के साथ। क्या मैं कंफर्म कर दूं?
हाँ, कंफर्म कर दीजिए।
आपकी अपॉइंटमेंट कल 3 बजे के लिए रीशेड्यूल कर दी गई है। जल्दी ही आपको एक कंफर्मेशन मैसेज मिलेगा।
I had to cut that short. Then it's about thank you, have a great day, and all those stuff which you're supposed to say, which we made the board say as well. Long story short, the call looks pretty simple, right? No frills, but it was a lot of engineering effort to make it look so simple. Because if you saw, the customer said, I won't be coming. That's a negative scenario. The board had to be like, oh, all right, you're not coming. What should I do next? It has to change context. In this call, there are 5 agents that made the call possible. The first agent was just about introducing, hi, hello. For if it's morning of the day, say good morning. If you're talking to someone from Tamil Nadu, say vanakkam. I'm from Kerala. If you're talking to someone from Kerala, I don't think there's anything called as vanakkam, but you say good morning, right? If you're talking to someone from North, speak in Hindi. So the introduction agent handles that part. Then there's a customer management agent which figures out, okay, whom am I talking to and why am I talking? Okay, this is about your doctor appointment. Third agent handles the situation. What was the situation? The customer was supposed to show up and she's like, oh, I won't come. Now that goes to an escalation agent, which means there is an exception. When you write code, you have try catch, right? Or try except. So the exception agent kicks in. And now the exception agent doesn't know how to introduce the bot, but then it knows how to handle the situation. It looked at the situation and I told, okay, I can reschedule it for you. And then you have to make an API call to the DB to check if the next slot is available, right? And the customer told, I'll do 3 baje. It's not 3:00 p.m. AM. When you say 3 baje, why can't it be early morning? That's also 3 o'clock, right? So that's where that agent is capable enough to understand. Say I'm talking to this person about a doctor appointment, it should be the evening. And then there is an API call handling agent, an agent specifically for tool calling, right? And that agent goes and calls the right API to confirm and tell that, okay, your appointment has been moved. These are like literally 5-6 agents in that single call, but I'm pretty sure you did not notice the latency in switching. Did you? Almost no, right? That's where Elasticsearch comes in. We use this in-house approach of storing agents inside Elasticsearch so that we know which agent to switch, when to switch, and switch in lightning fast speed. I'll show you the architecture for that now. Now let the numbers speak. So in insurance, there's this big issue of customers just hanging up. You say hello and the customer hangs up. Even though that looks small, talking to a customer with an AI bot for more than 60 seconds is phenomenal, right? I'm not saying it because I built the product. Try revisiting your calls with a sales agent. You would not have spoken for more than 60 seconds. Right now, our AI bot did it. We internally call her Aisha. 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 So Aisha is able to pull off 20% more conversion than what a normal human agent would do. And then 24% jump in one-time closure. What do you mean by one-time closure? If I call a customer for sales, for feedback or something, and then the customer agrees in the first call, that's one-time closure. And then Aisha handles 1,500 calls every day. And we are running short of on time here. I've just got 2 slides about the architecture, then we'll move to Q&A. So how does this multi-agent system work? If you look at this picture, it's self-explanatory. I'll take 15 seconds to explain. You've got an introductory agent, which is an SLM. It's not an LLM. What's an SLM? Yeah, exactly. It's a small language model. It's curated to do one thing very well, but it can't do everything. It's master of one trade, but not a jack of all trades. These are open source SLMs which we've either distilled or fine-tuned. It's not the straight of Hugging Face model. These are the different ones that we have. Now, where are the prompts and the context stored? That comes from Elasticsearch. Now, when I talk to, what's your name? When I talk to Sanjeev, if I call him every time and say, hi, I'm calling from Bajaj Finserv Health, he'll be like, dude, you spoke to me 5 times. Now tell me the thing, right? So Elastic summarizes and maintains the context call over call. So when you do the nth call, your entire contextual summary from 0 to n minus 1 call is preserved. And we use Elastic's semantic compression for this. More about that online. Please do read about it. And then if we zoom in and see what does Elastic bring to the picture in the entire thing, one is semantic search. So if I ask, can I claim insurance for my dog from a policy? The bot doesn't know. It's again contextual RAG. It's a keyword RAG to Elastic, which again answers. But why is it such a big thing? You need response within 50 milliseconds because the guy is waiting on call. You can't respond after 3 minutes, right? Session memory, this is what I told you. Metadata for rehydration. When you're making a call to the customer, you have to rehydrate the bot to tell the bot what was spoken over the last 6 days so that the bot doesn't start afresh. Arbitration ranks next based agent or action. So I told you there were 6 agents in one call. Now, how does the LLM know which agent to pick next? We use the semantic ranking algorithm from Elasticsearch straight out of the box without any modification to figure out which agent can handle the situation. Once Elastic says this is the agent, we switch on the fly. Again, almost 50 milliseconds delay. The customer should not notice. Compliance and audit, I'll skip that. That's primarily for insurance. Analytics, we use dashboards on Kibana to see how many calls successful and all those stuff. Personalization is what you just saw. If I can talk basis my policy, my doctor slot availability and all those stuff. This is where Elasticsearch comes into the picture. Use cases literally wherever you need to call, right? That's pretty much from my side. I think we've got some time for Q&A. If you guys have some questions, please raise your hand.
Thank you, Blessin.
Yeah.
I think he has given how agentic framework works, how he is using all the voice systems in production pipeline, and you must have given more understanding. Feel free to probably grill him with respect to questions.
Yeah.
We are pretty much it. So
see, so when I don't get questions at the end of my session, right, there are 2 things. One, I did an extremely great session that everyone understood everything, or I did a very bad session that no one understood anything. I'll go with the first.
It's okay. I know this is after lunch, so you're a bit sleepy, but this is the time when you come up. We talk about your experience. Feel free to ask him questions. He's available offline as well. So if you don't have questions, please feel to take it. Yes.
Yeah. Sorry? Since you deal with voice and the systems are real time and you need to compare, how do you deal with setting up guardrails? Oh, fantastic question. I did not want to cover this specifically in the session because that will derail us in a whole different level. You're Gyan, right? Yeah. So primarily the challenge here is that you don't have time for setting up guardrails between conversations because it's real time. So we use something called as XML prompting. We don't use English prompting. And if you don't know what's XML prompting, you should read this article from Anthropic. Anthropic has written a very clean document about how you should write prompts with XML. And I can confidently tell you we've almost killed hallucinations once we move to XML prompting, and that's how we handle that internally. All right. Any other questions, anyone? I
Perfect.
think we are good for the day.
Yeah. Thank you. Thank you very much.
Thanks, everyone.